All right, good day, everyone. This is Jason with the Cloud Pass Virtual Group. Our presentation today is Azure Data Factory Design Patterns with John Miner. Before we get started today, I just have a couple announcements. There we go. The Pass Cloud Virtual Group is brought to you by Microsoft Azure. Microsoft Azure helps to support this group in hopes that folks will take a consideration in going to Azure as they're building out their data platforms, and also just to try and make sure that folks have an opportunity to learn more about the possibilities that you have with your data platforms when you're bringing them to the cloud. If you are not yet a member of the Cloud Pass Virtual Group, I do recommend doing so. You can go out to cloud.pass.org to become a member, and that'll get you an access to our newsletter, which will let you know about upcoming sessions. And so we try to have a session, 2 sessions per week on Tuesdays and Thursdays. Got plenty of openings in the next couple months. So if you are interested in presenting, please just reach out to us at cloud@pass.org and we'll get you onto the schedule. Alternatively, you can go out to our call for speakers form that's out on the cloudpass.org website. Coming this fall, either in person or virtual, will be Pass Summit 2020. Pass Summit 2020 is the premier Microsoft data platform conference. So it's really the best place to go to learn more about building data platforms with Microsoft technologies. If you have not yet registered, you can get $150 US off of your registration by using the discount code there on the screen. If you need me to, I can send that over to you. This virtual group is part of a number of virtual groups that Pass helps to put together. These focus on a lot of different areas: data science, virtualization, and women in technology. So if you are looking for other areas where you've got some interest in learning, there's plenty of opportunities out there. Throughout the session, I expect a few of you may have questions, and if you do, please type them into the question panel, and then at the end of the session, we'll go over those with John. And those are our announcements. So our session today is Azure Data Factory Design Patterns with John Miner. And let me make him the presenter. All right, there you go, John.
Awesome. Thank you, Jason. And again, thank you for inviting me to talk at your user group. Let's go up to the top of the slide deck and do a little introductions myself. So I will promise that I will not do too many blurbs for different things I belong to, but I do have some things I want to mention. So again, my name's John Miner. I'm a data architect at Insight Digital Innovations. And today I'm going to be talking about Azure Data Factory and design patterns. Azure Data Factory has been around for probably about 5 years, and various changes have occurred during that time. So we'll talk about that. A few things I'd like to talk about is I am an MVP. Hopefully it's my 5th year that I'll be becoming an MVP. And I love presenting at user groups like this. There's a couple things I want to talk about. So again, if you are in need of talented people, please reach out to me or someone at Insight Digital Innovations. We have about 1,000 consultants there. I've been on and off the group president for Rhode Island User Group. We do meet the first Wednesday every month, and we're virtual now. So we've been actually meeting for the last 10 years. I took over the group from Grant Fritchie, and you can see that we have 86 posts here online. So yeah, we've been meeting for a long time. If you really like what I talk about and are interested in more Azure topics, please go out to MS SQL Tips. I am an avid writer there. My goal this year is to get 75 articles total, and that's almost 250,000 of written words. And one of the things we're going to talk about today, if I can find it, is some telemetry. So it's going to be one of our examples we're going to talk about. And telemetry is one of those things in which you capture stuff from like a connected device, okay? And how many people have actually went and got a soda machine? And again, this is a soda machine here. This is old school. This was 1929. And you know, when I was growing up in the 60s, late 60s when I was born, but early 70s, they still had these machines. So we'll talk about a modern use case of that, as well as you know, how you can ingest telemetry, which would be a Lambda architecture, a batch processing lane. And then we'll be also talking about how to do a simple report. And so, but we need to get some background before we actually start getting into Data Factory, right? So let's stop there. Okay, terminology. The movement data can be defined as a series of steps categorized, extracting data, translating, and loading. I've been in the industry for about 30 years, and when I first came out, Microsoft Quick Basic was the popular tool at the time in 1991. And there was no such thing as storing data in a database. It was stored on file. And if you remember Novell had something called btrieve, and it was a binary tree, and it was a record manager, okay? So that's where I started out of it. But
John, real quick,
yeah.
Can you click on the display settings to swap between the presenter view and the yeah, you had the wrong slot, you had the wrong view up on the main screen.
Yep, let me see, which one is it? This one here? And
yeah.
which one do I need?
So if you go on to, if you start the slide deck again.
Yep. So this is slideshow.
Yeah, and then on the top there's that display settings.
Let me see if I can get to it.
Yeah.
Let's see. Oh, right down at the bottom.
It's at the top. It's show taskbar, then display settings, and then end slideshow.
Yeah,
it's on the presenter view where you've got the two slides showing.
Okay, so I got screen, display settings, swap presenter view and slide view. Is that what you want, or you want me to duplicate?
Swap it. Yeah, there you go.
Okay, you like that?
Yeah, now I can see the full slide.
Okay, sorry about that, guys. Let's start again. So again, we're going to talk about Azure Data Factory design patterns. I am going to try to keep it to an hour. It'll be tough though. There's a lot of things to talk about. Like I said, I started a long time ago in this industry, 30 years ago, and most of the stuff was file-based. Okay, there was no SQL, there wasn't SQL Server, or all these appliances that we talk about nowadays that you can deploy to the cloud. One of the concepts that's still in play though is that, you know, system design, and is it tightly coupled or loosely coupled? Okay, so if you do a tightly coupled design, okay, when you go ahead and you change the source producer, okay, or the destination producer, guess what? You're actually changing the whole system, because, you know, it's, you have to go to the program that does it. With a loosely coupled design, what we're doing is we're using a man in the middle, right? Like a data lake. And so any checks, changes that affect the whole system, only a small section of the system needs to be redesigned, okay? So you know, nowadays everyone's pushing a actual data lake, but this has been a design pattern that's been out there for at least 10 plus years. And it's basically the hub and spoke model, right? So in the middle, we have a hub, okay? And that hub will be a data lake. Now I have S here for the spokes, but you can label any of these spokes as either a producer. So I'm producing data and writing it to the data lake, or I'm actually reading it from the data lake, okay? Now, a lot of people are still using this technology, but where the hub is, they might be using an operational data storage, right? That's your data warehouse sitting in the middle, right? Or your ODS, right? And with big data, because the operational data store is really expensive to actually store data in, and we have structured as well as non-structured data, we might store it in an Azure Data Lake storage, okay? Some people use the data lake storage to be the single source of truth for the company, which is one way to go. So there's two types of file types that you can actually put into a data lake, right? We talked about unstructured. We can also talk about weekly type file formats, okay? One of the formats that I try to steer people away from, but they love to use, is comma separated values, right? And this could be a CSV or TSV for tab separated values. The problem with this is that if the data is contains the actual delimiter character, then it can be easily broken. Some of the more popular formats that are being used with big data, and especially Spark, are the Apache Parquet format. And I like the Parquet format because it's strongly typed. You know that a name is, first name is a string, and you know a social security number is maybe a string, you defined it, versus a number, right? If you're using CSV, you have to read up the whole file and do a scan before you actually figure out the type, and that's called inferring the schema. Also, Apache Parquet allows for compression. That means that it uses a column data store and you get really good compression techniques. I've been doing a lot of work lately with Azure Databricks. And so one of the things I want to talk to you about is the next generation of the Parquet format called the Delta file format. Databricks came up with this, and it actually supports ACID transactions, okay? So you can have one person reading and writing at the same time and not having any file locks. One of the things I also like is schema enforcement. So make sure that the data that's going into your data lake is the data that you want. They have an interesting concept called time travel. Now, time travel, you can set up the versioning of the Delta tables. By default, I think it's 7 days, but we can say, hey, we want to keep 30 days online. So this is going to take more disk space, but we can go back in time and actually see where a snapshot of the data looked like before, say, a load. Again, this make sure that snaps out isolation is, you know, part of this design, so you can have multiple readers and writers at the same time. And the cool thing is it's open source format, okay? So the data lake, and one of the things when you talk about data lakes, and again, I'm talking a lot about data lakes because that's where I see the industry going. I mean, we can also talk about data warehouses, but data lakes are usually broken up into different quality zones. And a lot of people, you'll hear them talk about bronze, silver, gold. They sometimes refer to it as the raw zone. So we're putting a file, say the VentureWorks file, which has, say, customers, into the raw zone. That means we didn't do anything to it. We might have something called the processing zone, okay? And what we will do there is we may join the customers to, say, account number or address or something to enrich the data. Maybe we can, you know, say how many times they went to our website, right? And then the curated zone would be the final zone, which we would actually have the best quality data for AI and reporting. So load patterns. When you look at how you load a database, there's really 2 patterns you can talk about. I mean, there's a bunch of sub patterns, but the main pattern is a full load. So usually this basically replaces the target data set with a completely new version. If you are a SQL Server DBA, you might want to go ahead and use some schema swapping, okay, and that can be easily done. So you write to, say, a stage schema, and then what you do is you do a metadata change to swap, you know, your active schema to a temp schema, your stage schema to active, and temp back to stage. So if there is a problem during this processing, you'll always have a copy there. You just have to revert to it. The incremental pattern load pattern is a little more complex, right? So we have to load to that stage pattern table, okay? But at that point, we want to actually determine if there's an update and insert, and possibly if you're doing deletions, right? Some people decide to mock deletions versus actually doing real deletions from the data set. The problem nowadays is that data is getting really huge, right? And so one of the things you have to think about, especially with Azure, even between services, is how much data do you want to move across the pipeline? Everything in Azure is a REST API call, so that data movement actually takes time. And not all storage is local, so that means that there's increased latency between the 2 devices, right? So at that point, you might want to think about partitioning your data and using an incremental pattern so you work with a subset of the data, and this increases performance. So let's talk about a little background of Azure Data Factory. It was designed as an orchestration engine, and it was released in 2015. I looked at it in 2015, And like many Microsoft products, I usually wait for V2, okay? And so when V2 came out, I thought it was more mature at that point and I could start using it. That came out in 2018. It excels at connecting and orchestrating and delegating the management of movement of data. And one of the things it's really good at is it's good at connecting to legacy and modern environments, okay? So the problem you'll find is that with Databricks, you can only use data that's in Azure. With mapping data flows, all the data has to be in Azure, okay? But if you use a self-hosted integration runtime, which we'll talk about later, you can actually reach back to on-premise and get legacy code and or data and move it to your modern environment, which would be Azure. Last but not least, we'll talk about wrangling data flows, okay? So the very first pipeline in 2018 was just regular pipelines, which uses this ELT design. Mapping data flows went to ETL design, okay? And wrangling data flows is still in preview. And due to the fact that it's still in preview and I've seen bugs in it, I would not, develop your whole world on it. I think it's a great concept. It's just not there yet, okay? And it uses the Power Query interface to simplify transactions using the M language. So business problems. When you create a bunch of pipelines, why use naming conventions and project folders, right? And you want to compare these two designs. What's the difference between an ELT design in which the compute is always done somewhere other than Azure Data Factory versus ETL design? And is there any cost benefit trade for each pattern, right? So these are the kind of questions that you need to put in the back of your mind. And we'll talk about them today, and you can explain them to the decision maker who's actually going to approve the project that you're working on. One of the things that is a pet peeve of mine is comments and naming conventions, okay? A lot of times as a consultant, I go into a place and there's not a single comment. I just recently worked with a client and I had to develop about 15 new Databricks notebooks, and I had to rewrite 5 of them, and they were just totally impressed because when I was done, I used the very simple concepts of A, documenting stuff, B, using the same naming conventions or design patterns so everything looks the same, okay? And the last thing is just make it modules, right? Each cell in the notebook should do one thing and do it really well, okay? So there is a bunch of components that make up a pipeline. We're going to get into that shortly. Usually there's a link service, and that is where the connection information is to a data set. A data set defines what the data is. So say if it's a table, an activity is like a copy activity, it actually moves data, okay? And so when you actually go ahead and create a pipeline, you might want to use a naming convention, okay? There is some comments in Azure SQL Data Warehouse that you can, Data Factory that you can use, but they're not really that big. I always like name conventions because if we put this together, we can see that we have PL for a pipeline. The action is going to be copy data. The source system might be an Oracle database, and the destination system might be a SQL database, okay? So again, you don't have to follow these name conventions. At the very end of the slide deck, there is a sample one that someone did, but you should have your own and maintain them, okay? So organization of projects, right? One of the first things you can do is that when you define pipelines, when we'll get into that soon, everything gets defined into one little tab. So if you have 100 pipelines, there's 100 different entries, objects. Problem is this can get quickly uncontrollable, okay? So one of the things I suggest is that you use folders to organize pipelines, data sets, and data flows. Azure Data Factory is not like SSIS in which you can do annotations inline, okay? That means that when you connect objects, you can't show, hey, this is doing this at this point. However, you can put a comment, okay, in there talking about it. Also, you can, put some type of short algorithm if you need to. The best thing is to have good documentation that goes along with your pipeline so you understand them. And when you're developing, you can connect Azure Data Factory to Git or any software version control that you like, Bitbucket, etc. Okay. Git integration is pretty straightforward because it's the part of DevOps, and that's something that Microsoft supports really easily. So let's talk about the pattern of ELT, extract, load, and translate, okay? Basically, the copy activity is the center of attention using this design pattern, right? So you're copying data, say, from the VentureWorks SQL Server database that you don't have any access to in the cloud. Okay, it's on-premise, and the data might go to the Azure Data Lake in a Parquet format. That might be one way. So this copy activity is the center of this attention for this. Data is moved from a source to a destination. The problem is, how do you go ahead and you do the translation? Well, the problem people complained about is that there was never any way to do it in the tool, okay? So one of the things people started using is SQL Server, okay? So you can call a stored procedure. So say if I copy from on-premise database to a staging table in the Azure SQL database, I can run a stored procedure to say do that upsert into the final table, okay? Another popular technique was using USQL. However, I would not suggest using USQL because Azure Data Lake Analytics, which is USQL, is now deprecated. Microsoft is no longer supporting that product. Instead, I would suggest using Databricks. Databricks is based upon Apache Spark. It's really great because it's a integrated development environment that's easy to use, and you can quickly get started on your ETL design patterns. So let's look at a diagram of how Azure Data Factory works, okay? So again, at the beginning, you want to define a link service. And the link service, okay, is the connection information. How do I connect to the Azure SQL database? How do I connect to the data lake? Okay. Once you connect to the data lake, how do I know what the file is? You might not, right? Parquet is really great because it's strongly typed, and the data lake, Azure Data Factory, can infer the schema from it. Okay. However, CSV might not be so good. It might infer the schema and come up with the wrong type, so you might want to change that. Okay. After you have the data set defined, okay, the next thing is you want to do something with the data set, and that's when you create a pipeline which has a bunch of activities. One of the activities might be do a lookup into a control table to find some metadata. Next activity might be from the metadata, do a copy activity. The last one might be from the metadata, execute a stored procedure. These are all common patterns that we can use, and we're going to go over one of those on how to do parameter-driven data flows. Okay. Once you have the data flow, how do you actually schedule it, right? And that's what a trigger is called. Okay, it's just a different word for how do I schedule my pipeline. Last but not least, just like most Azure SQL products or Azure products out there, you can define some type of alert, right? So I can say, hey, if my pipeline failed, then notify someone in the middle of the night that, hey, that job failed, it's time to go look at it. One of the things I did want to talk about is where I think Azure Data Factory excels, okay? Azure Data Factory excels in the hybrid data movement, okay? So in this diagram, we can see below is on-premise and above is Azure Data Factory. By default, you get the default integration runtime, okay? And it can talk to any services that are native to Azure. However, if we have SQL Server, which we can see at the bottom, okay, with the little tornado with the red, right, SQL Server, then how do we do that? Well, we can go ahead and install a piece of software on our VM, okay, in between the cloud and on-premise, as long as there's a VNet connectivity flow between the subnet from on-premise to the cloud, you're all set. Install this piece of software called integrations runtime, self-hosted. And what this does is it looks for a job. Now, if you peel back the covers and you look at the white pages, you'll see that Azure Data Factory is built upon Ooh, I'm drawing a blank here. Sorry about that. You'll come to me anyways. It's depend upon a queue, right? And in this queue, you'll get a job posted on the queue, okay? And what the integration runtime is going to look at the queue and say, okay, it's time to do some work. Here's the source, here's the destination, here's the connectivity, let me take that job. One of the things people do when they do this hybrid data movement, they go ahead and they duplicate, okay, the integration runtime. So there's two of them, one in maybe two different data centers, or at least the machines on two different racks, and you can do that by setting affinity. But regardless, you want to make sure that both integration runtimes don't go down at the same time, say for patching or for an outage, so that this process keeps on working. And so, by the way, that queue is called App Fabric, right? And so the service bus, and that's where the actual job gets put on. So again, it's a lot of complexity going on here. So do we have a lot of extract and translate activities? And the answer is yes, okay? So let's take a look at, I took a quick screenshot of all these and I put some comments on them. So I think where things are going, okay? So the copy data activity is one of the activities I use all the time. Data flows are new. We'll talk about those pretty soon, okay? Azure Functions, great. I hardly ever use the batch service because it's usually for big data and you have to write a C# program, so I'm not into that. The Databricks, the notebook and the Python are great ways to go. Like I said, USQL has been deprecated, no roadmap, okay? Anything on the general is a perfect thing that can be used. For instance, I want to append it to a variable. I want to delete a file. I want to execute a pipeline. Going back to this, you can actually install a integration runtime for SSIS. So if you want to lift and shift your packages into Azure SQL Database, you can, and you can schedule the execution through, okay, this product. The lookup procedure is great also because you might want to have a data metadata stored about your pipeline. And what you do is you do a lookup into the metadata and you find out what you want to do, and then you do a for loop, okay, to actually go through it. And so that's your iteration and controls. One of the things I'm going to kind of try to, push you away from is HD Insight. While HD Insight is out there, it has a version of Spock which is out of box. It's not as optimized as the Databricks version, and there's not a lot of support. You would have to go ahead and do a lot of things that are automatically built into Databricks, like security, connectivity to Azure Key Vault, etc. Those things are not supported out of the box. Also, map reduce using machines takes longer to process than stuff in memory. So therefore, I'd be pushing Databricks, okay? Last but not least, I'm going to just skip over this, but I want to mention it. You can do some ML learning, such as components here. And again, I don't do that too often. So let's get into some examples, right? We're going to talk about two examples. One is an IoT streaming example. I've been running this for the last 3 months. It probably has a couple 100 million records, okay? And it's that soda machine, okay? So what we have is we have a PowerShell script that is writing a bunch of records via telemetry from the soda machine to an event hub. The event hub is actually using a stream analytics job to drop the data into blob storage. And a data factory job is picking up the data, stick it into a SQL Server staging table, and then upserting it into the final table. So that's the very first design pattern I want to show. The second one I want to show is when we've done this with a lot of clients is a cloud reporting or a modern data warehouse, okay? So you might have an on-premise SQL Server, okay? And from that on-premise SQL Server, you want to reach back using a self-hosted integration runtime. Now, a lot of people with the self-hosted integration runtime, you have to be part of the same VNet, so there has to be some type of connectivity setup. The cheapest way to do it is a VPN. That assumes that on-premise you have a virtual private networking device, say something from, I'm just guessing, Cisco or Barracuda, something like that. And there is a list of approved devices from Microsoft that you can use. Second one, and again, VPN goes over the actual public cloud, okay? ExpressRoute is something that takes up a lot more time and money to set up, but is totally secure. The reason why is you're not going over the public cloud. You're doing a point-to-point connection from your, data center through a provider, say Verizon, to the Microsoft backbone, okay? Again, we're using Data Factory to read from on-premise, store to the data lake, say in a Parquet file, and then write to Azure SQL database in the final result. And we can use something like a Power BI service to report off the data. So I know it's been a lot, but we're going to get into these two examples, and then we'll talk about mapping data flows next. Let's see if I can find the right one. Okay, I'll leave that one up, and I'll go up one on this one. Okay, so I pinned a lot of items to this dashboard. And so this is a typical, solution I usually develop in Azure. Okay, so it has a bunch of different components. So I write for MS SQL tips, so that's why they all have the word tips in them, but let's go over them. So I have an Azure SQL database, okay, called DBS for tips, and I have a SQL server. Okay, this is a logical SQL server. Interesting thing is Event Hubs is almost like Azure SQL Database, in which we have, okay, a namespace. So it's Event Hubs namespace, and within that Event Hubs namespace, we can have more than one Event Hubs. Event Hub is just a way to collect telemetry. Okay, it's high speed, lots of data, and it's for big data. So let's take a look. Hopefully, it's didn't log out. Awesome. So this was done pretty much quick and dirty. I just wanted to show people how to do it. I'm using a PowerShell. Actually, yes, this is PowerShell. I'm using a PowerShell program script to write to the queue every hour. So every hour, I'm randomly generating some data. And if I remember where the data for the script is, I think it's on the C. Is it? Nope, one up. Okay, so we can see that this is, we have some supporting files like, hey, what's vending? So we can see that we have some random numbers from given at, midnight, the minimum sales 2 soda drinks and max is, I'm at 0 and min is 0 and max is 2 and so on. We can see that, obviously during the hours that suddenly approach, noon time, a lot more people at the college are drinking soda, okay? So that's kind of one setup file. We can see that slots, okay? So if we go back to this, we can see that's the old-fashioned one, but this is a modern day machine that we might be talking to, and this has 45 different slots, and each slot we're vending a certain product, right? So we have to have that information somewhere, and so these are all support files to the program that runs and sends the telemetry to the cloud, okay? So we can peek at the telemetry. So if we go to Event Hubs, we can see that there is some different consumer groups. A consumer group means a person can read from that Event Hub. And so if we go into process data, it should ask us if we want to view stuff in the hub, and we can explore that, okay? So this is like almost like stream analytics. It allows us just to peek at the data, not all the data. And if I click it, we can see that we have the slot, so it tells me where it's located in machine. We can also look up what college the machine is at, given a machine ID. We can see what product's being vended, when it was vended, okay? How many counts, so every slot's gonna report something, regardless of whether or not it vended something. And then that's it. The rest of this information is actually coming from Stream Analytics. We're not really too interested in that. So the question is, so it goes to Event Hub, how does it actually get to, Azure Data Lake or Blob Storage? Well, the thing is it gets to Data Lake Blob Storage by the Stream Analytics job. So jumping past the Stream Analytics job, and I'll have to open that up in another window, we can see the output is actually being generated into a directory. So we can see that 16 is the current directory. Okay, that's hour 16, and we can see there's a file there. Okay, and if we click the file, we can click on it and hopefully do a download. We can take a quick look at it. And this should be the same file that you saw before, but through the quick process data in the Event Hub. So I'm going to show in folder, and it's coming down. It's about 33 megs. It says it's unconfirmed. Let's see if I can get to it. Come on. Show in folder. And here we go. So if we hit the edit notepad, we can see that we're actually getting the same data we have here. The interesting thing is we really don't want this event process ID and partition ID in the final solution. So let's see if we can get rid of that. Okay. So let's go to the Stream Analytics job. So the Stream Analytics job is a very simple job. They can be a lot more complex. This one actually says select from the Event Hub and write to the storage, which we already saw. Okay. So let's look at the last component, which is basically let's write a job to actually process the telemetry. This is the transaction soda telemetry. Okay. So we can look at data flows. I meant data sets, right? And we can see there's some data sets here. And the very first thing I said is that we want to look at linked services, right? And so we can look at connections, okay? And so we can see that there's some connections here. So the very first one we can see is that this is Data Lake Storage Gen 2, okay? And we are using a managed identity, and we can see it's actually going to the storage. And we define the actual connectivity here, so it's using a managed identity. I had to actually add blob storage reader as a RBAC control, okay? And again, this gets a little complex. I'm just going to show you how it works and gloss over a few things. But we can see that there is ABL pseudo telemetry, right? And this is the JSON file that we were looking at a minute ago. So if we look at the connection, we can see that it's under blob storage, okay? And we can see that we're going to use some parameters. So we can say there's a string, which is the directory I want to look in. So we can see that the most recent directory is not this. So if we went back, we could go to storage account. And again, the other one I used when I was prototyping it, so we can quickly change this and see if it works. And this is how, when I develop a pipeline, this is how I go ahead and actually debug it. So the first thing is I create a link service. Then the second thing is I go ahead and add a parameter, because parameterized queries are pretty good. And so we can see this is 528.17. So if we go to here, we can do 5, right, 28 and 17. Cool thing about this is that we can go to schemas connection and we can hit preview data. And it picked up my new parameter I just created, and I hit OK. And we can see it's pulling the same data that I actually pulled down, okay? When you make changes, you have to publish them. So I'm going to publish it, and it will automatically publish it locally, okay? If we had been connected to a Git, we'd first develop in Git, hit save, and then we'd publish to the actual development environment, okay? So now that we've actually looked at the source, right, let's look at what the process is going to be to update this. So we need to first get a look at, hey, what's the last hour that we process some data, right? So if we preview the data, we can see that the next hour of the process is 18. Well, we know that doesn't exist yet, right? Because we would have to go back and reset this, okay? which we could, but I'm running out of time, so I will not do that. So that's our lookup. This is grab the watermark. A watermark is a very defined design pattern. Okay. Second thing is set the variable. One of the things we want to do is we want to set it to a value. So we're doing a replacement using the actual expression language in Azure Data Factory to replace it. Last thing we're going to copy. Okay, and this is a copy. And the source is going to be blob storage. The sink is going to be data events. And what we want to do is, since it is a staging table, we want to do a pre-copy script and we want to truncate. So that eliminates us from calling a start procedure. And then we have two start procedures we want to do. We want to go ahead and we want to upsert into the final table. And then last but not least, we want to, okay, update the watermark, okay? So let's see if I can figure this out. And maybe I have this in this window, let's see. Nope. Okay. So let's go home. Basically, I think I might have lost my connection string, so I am just gonna go grab this for the SQL database and we'll go see if I can log in. Hopefully the password didn't change, so Control-C. And minimize this one, close this one. And Control-V. And I want to do this, JMiner. And I'm probably gonna have to open this anyways. Okay. So let's take a look at this database that I'm playing with. So if we go into databases, we can see the very first one is for the tip that I wrote, okay, for telemetry, for MS SQL tips. And we can see that the current watermark, if we edit it, okay. What I'm gonna do is I'm gonna set this up for a test. So we're gonna reprocess the 17-hour because we know that we're automatically writing to the data lake, so and it's in Azure Blob Storage, and so I want to reset it back by an hour. So I'm going to say, hey, let's reprocess last hour. Okay, and if we select from this, okay, we can see that's done. And we can select the first 1,000 rows from the slots. But remember, right, it's about 152,000 entries here. And so I'm going to execute it, and there it is. I'm going to truncate this, truncate table. And then we're pretty much ready for a test. So now I've backdated the watermark, I updated this, and it's going to upsert. So if you're curious, all this code is again out on GitHub. So if you do a quick search of John Miner, let's see if we can do it in Google, we'll probably hit it right away. So John Miner, GitHub, and John Miner. Right, because I'm the third. There you go. And all my presentations are out there, so you can download this code and play with it. So Azure Data Factory design patterns, of course, only directory you don't have is my password for my VMs, okay? So let's kick this off and move on to the next pattern. So if we hit trigger, and we could do debug, but it's going to run it locally, but we're not going to get anything output. So I'm going to publish all. I don't know what I made changes to, but I'm going to say, yeah, whatever. Hopefully I didn't break anything. And then trigger now. And this is actually going to put it in the monitoring section, okay? So I'm going to stop running this, okay? And we can see, if we go down to monitor, we can see it's actually running. So if we click into the job, which we just triggered, we can see each one. Interesting thing I like about the job is that you can look at the before and after. So we're calling this data set, right? And we're saying select the process date hour from staging, right? Current watermark. And if so, we run it again, and we can see we picked up the 1700 hour, which I wanted. And then we can see we're creating this variable, which has the directory, which paths to the correct directory. And then we can take another look, and we can see that we're actually getting this data, okay, from the JSON file, and we can see it's a copy commands going on. So if we hit refresh, okay, it says it's still, so it finished. So if we take a look at the final, we can see it brought over 152,000 rows, okay. There was 9 connections. It went pretty fast. It took 19 seconds, so it's really quick. Last but not least, if we hit refresh again, there's 2 more commands, right? We did a upsert, so this is in progress, and this is going to take a little while because there's millions of records, and then we're going to update the watermark, okay? So I'm going to, oops, it finished. I was going to say I was going to jump to the next demo, but we can see that this one, it went ahead and updated it and just gave us how long it took, nothing big, and we can see that the new value. And this one, we can see that it took some time, and that's about it. So you just need to verify that it worked correctly if you were designing this from the beginning, okay? So let's talk about doing a modern data warehouse, okay? So there is a couple of patterns we can talk about. We can talk about a child full table load, okay? And that was one of the things we do. So again, we have to get access to this server right here, which is VM17. And in this VM17, we have the VentureWorks server. Okay, how do we do that? We have to install the self-hosted integration runtime. So we can see that this has been installed, okay? And if you do in Parquet, you're gonna have to install Java also, okay? And you can see it's been connected, okay? How do we know that this is, you know, not a public IP that anyone can get to, okay? If we hit dashboard, okay, we can go to the virtual machine, okay? And under the virtual machine, we can look at networking. And if we look under networking, okay, we can see that there's no rule for 1433. That is the default port to talk to on SQL Server. So right now, this has been locked down and we cannot talk to this. We have to use the self-hosted integration runtime. So if we go to connections, we can see this integration runtime. So we can see that the Shire's here, which is the self-hosted integration runtime. It's running. We can get information on it if we really want to. We can say, hey, you know, is it highly available? No, because we only have one of them, right? We can see how much memory is. Is it being used right now? 0%, right? And so on. So is it reading for the, you know, the app fabric, okay, which is the queue? Nope, it's not doing anything right now. So what we do is to build upon that, we have to create our data sets, okay, using that. So if we go to MS SQL, when we define this data set, instead of using a regular connection, we want to use the MS connection, okay? Now, like I said, variables are very important. So say if I had a bunch of things I wanted tables to actually copy over, I'd want to put the default schema and the variable table name, okay, as 2 parameters, so DBO and dim customer, okay? And, you know, we can preview the data, and this is actually going to go out, use those 2 parameters, and come back with the data, okay? So let's see what our full table looks like versus the incremental, okay? So for our full table load, first thing we're going to do is we're going to set a variable. And this is basically looking for a Parquet file, right? Then the second thing is we're going to create a truncate statement to truncate the right table because it could be dynamic, okay? And then we're going to do a copy, and the copy is going to go from the lake, okay, which is the source, okay, to the sink, which is going to be the path to write the Parquet file in. And then last but not least, we're going to go from the Parquet file to the sink, Okay. So with that said, okay, the reason you would say is, hey, why are you not going from the source to the destination? And we did this as a design pattern to go ahead and use a data lake in between. And in fact, if I was truly trying to make this as a disconnected or a loosely coupled program, I'd have two programs. I'd have the first program do the setup of variables and copy to the source, the data lake, and the second would copy from the data lake Parquet to the destination. And this one I combined them, okay? I'll let you make that change if you wanted to. The interesting thing is if you look at parameters, we can see that we're passing a bunch of parameters here. So we're saying, hey, we want to go from the source scheme is DBO, my target scheme is DBO also, my data lake is this directory, my path is the bronze zone, and the data lake file name is dim customer, okay? So if we go back to, let's go to this one, storage container, right? And is this the right one? Probably not. Let me double check, probably in the wrong directory. So Parquet file, this is where the Parquet file is gonna be. Connection, where's the connection? LZ, AZ, Azure Data Lake Storage, and we can look at connections, and the connections, Azure Data Lake Storage Gen 2, and we can see it's a storage account, ADLS 2020. So if we look at this storage account, ADLS 2020, well, this is not it, right? So here it is. So of course I couldn't read. It's right next door to it. Too many objects here. And if we go into containers, we can see, boom, this is the data lake, and then there's the bronze, and there's a dimension, and then there's a customer, okay? So there's a single Parquet. Last time I did this talk was on 422. Okay, so let's run this now, okay, as a single job, okay? So this is only gonna run for that particular hard-coded one table, right? So if we hit debug, and those are parameters, boom, it's gonna run. So Jason, I know I have a couple more things to talk about, but I wanna take a break point right now. I think I covered a lot, and I've completely covered pipeline. So is there any questions?
Yeah, there is one question here is, can Azure IR connect to a storage account private endpoint, or do we need a self-hosted IR?
Unfortunately, when it comes to storage, other than Azure Data Lake storage or that, or say if you just want to do a file share on-premise, you have to go ahead and use an IR. In fact, I think you have to use an IR even if it's a share in Azure Data Lake storage. So I think that's the truth, and just double check it.
Okay, and then the only other question that was still out there is regarding the slide decks, and that person did find it all out on GitHub, so anyone looking for it can find it there.
He can't find it or can?
They were able to.
Okay, excellent. So everything I've done for the community work is under J-3 community work, and then this one happens to be called Azure Data Factory Design Patterns. I don't want to steal your time, but do you not have another 20 minutes or so? I can wrap up.
Yeah, I've got the time, and then it'll go to the recording, so anyone that misses, that needs to leave at the top of the hour, they can pick it up from the recording, and I'll make sure to have that posted by tomorrow.
Thank you very much. And again, I apologize for going overboard on this, but there's just so much to talk about, and you can see I just talked about the very first thing. I haven't even got into data flows as well as mapping, and they're pretty interesting things. Let's just go back to slide deck and wrap up why you would use one over another. I'll finish through the slide deck, and those people staying on, at least they can get that point, and then I can go back. So let's see, can you see? That's wrong, right? So let me see if I can get it full screen again. Hang on, the mouse doesn't want to obey me. Screen. Display options, spot presenter. There we go. Okay, so why would you do one over the other? DLT is a very inexpensive way to do this, okay? One of the things you can do is almost all the components can be parameterized. That means that the master pipeline, like I showed you, is going against DBO customer. In the next example, I'm going to show you how to run all 15 tables through it. And it's easy to just to do, right? The problem with it is that, you know, any type of transformation, you have to write something else, right? So for instance, stored procedures in the database do the heavy lifting, like the merging of the transformation, and you have to write one per each data set, okay? One of the things I like to use is views. So if you're doing complex queries that join a bunch of things to actually come up with the final data set to merge, okay, I suggest you do a view and then use that as part of the merge state. How do I go faster? Okay, when you have big data sets, it takes a long time to move data. I did a POC for a client this summer, or was it last summer? I think it was last summer. And we moved over 1 terabyte of data in like 45 minutes. How'd you do it? Well, you don't have to do this. You can actually do partitioning by passing a key, say a row ID or company. And guess what? Now you can run multiple copies of the same data set with a different parameter in parallel, and that can reduce the time, okay? There's a couple other things you can change. Batch size can be altered for the execution, and it might change overall timings, as well as the number of computes. I forgot what the compute term is for Azure Data Factory, but there is one, and you can increase that. So let's talk about the ETL overview. So what's the difference between what we just talked about and this? Well, the other one uses something that Microsoft created to, quote, use service bus and put a job out there and connect from A to B and do some movement. The ETL actually uses Databricks, which is kind of cool, right? So one of the things that it forces you to do, it has to be a cloud-born system, okay? So the source and destination for the data flow must be one of the 4 supported systems: storage, database, data warehouse, and NoSQL. And again, the data flows are using the Spark engine, okay? That's why it's going to cost you more, because the Spark engine obviously has to be a cluster. Each cluster, say, has 4 machines. Now you're doing 4 times the number of machines to run something. While parameters are supported for data flows and it makes things really easy to do, the destination cannot handle dynamic data sets, and it's one that's lacking, okay? However, if you do want to have more of like the SSIS look and feel and do everything in the cloud, then guess what? Mapping data flows will allow you to do that, okay? Now, one of the things I'd caution you against is wrangling data flows. It still uses, it doesn't use the Spark engine. It uses, I'm pretty sure, the integration runtime engine. However, it's based upon the Power Query interface, and it's still in preview, and it's been in preview since last November. So that's not a good sign to me that it's going to go GA anytime soon. And if you put your eggs in a basket that might go away, it's probably not a good idea, okay? And not all source data types accepted this time. When I was actually, we'll get into a example I'm going to use. I had to typecast a lot of stuff because the destination, it did not understand what a money was, okay? But if I changed it to like an int, it suddenly worked, or a float. So what are the components, okay? The components that you do for, you know, a mapping data flow, you have these. You can join some data sets. You can split out some data sets. You can see if something exists from one data set to another. And that's great for if you're trying to do an upsert. You can union 2 distinct data sets. You can do a lookup. We've seen that's very helpful. Things, derive columns, select the subset, aggregate. Say if I want to summarize something, I want to create a surrogate key. I want to pivot, unpivot. And also window functions are supported as a schema modifier. Some of the cool things about the row modifier are filter. So for instance, select basically just says, hey, I want 3 of the fields out of the customer, say like first name, last name, and middle initial. Filter says, hey, I want all the names that equal minor. Okay, so I just get the minor family coming through, okay? I can also say, I want all the people who have first name John, and then sort by last name to see all the people that have John in alphabetical order by last name. And also the alter row allows you to go ahead and mark a row as a insert, update, or delete. Not listed here are source sync, which is the destination, and whether or not you can add a new branch, because you can draw multiple pipelines in the same mapping data flow. And what we're going to do is we're going to eventually go over to data flow examples. And I'm going to say this is trickier than it should be. Yes, it should be pretty easy, but it is tricky to do an upsert. And we're going to talk about the aggregation data pattern. So let's talk about the pros and cons before we wrap up the final examples of both mapping and wrangling data flows. The data flow activity is called from standard pipelines. So if you have to copy over from on-premise to, say, one of the supported Azure systems, say Data Lake Storage, you still have to use a pipeline. Options such as partitioning, backslash, and isolation level do affect the performance, okay? In partitioning, I'm talking about Spark partition, and isolation level is how strict do you want the actual threads to talk to each other, okay? One of the things I suggest that you look at is the time to live, okay? So spinning up a Databricks cluster to run this takes some time, right? And if it takes 5 minutes to spin up the cluster, we don't want it to go to sleep after 5 minutes, okay? So maybe you want to keep it up for 2 hours. Some things do actually happen quicker, okay, in a regular pipeline than a data flow, mapping data flow, okay? The reason why is there's overhead for parallelism, okay? There is the really cool thing about mapping data flows is I like it is you can use advanced lookup and transformation steps. In the past, this would have to be pushed off to, or even nowadays, it would have to be pushed off to a SQL Server store procedure or a Databricks notebook. Let's talk about some monthly costs, okay? So one of the reasons why I like pipelines in general is it's really inexpensive. So if I just do a ADF, okay, and I did not include a virtual machine, which could just be a Windows 10 box, maybe it's an extra, I'm guessing like $400. It'd be that 262 plus 400, right? But because the Spark cluster is expensive, you're going to add an extra $2,000 a month. And I'm going to leave the summary page there, and we're going to go back to demos. Oops, come on. Is everyone still with me?
Oh, yeah.
Awesome. I'm just looking why my Alt tab. Maybe I need to get out of the presentation mode. Maybe this is stopping it. Okay, let's do this. I'm going to close the presentation. So, let's see if I can get to, oh yeah, there we go, finally. Awesome. So we ran this last time and we copied a full copy table, right? So what we did is we only copied one. So if we look, we're copying dim customer from the blob storage. And if we look at the storage which we were working with last time and we hit a refresh, we can see that there's a new version of the file for the customer data given today, okay? So how do we do this for a variety of tables, right? We don't want to, the idea is we parameterize it so we can do it for more than one, right? So the idea is that we want to do parent. Okay, let's see. So what we want to do is we want to get a lookup of the pipeline settings, and then for each pipeline setting, okay, we want to do something. If full load is true, then what we're going to do is we're going to run the full load type. Otherwise, if it's false, we're going to run the incremental type. And we can look, and the difference is here's our full load. And if we look at this, this is actually calling a sub pipeline, and it's passing all the parameters. Where do these parameters come from? Well, it comes from this item, and item is being passed from this parent, and this parent is the lookup. So let's take a look at the lookup. So if we go to settings and we hit preview data, we can see right now it's only doing one table, which is the fact, right? So let's change that. So we can change that by going to SQL, okay, minimize this and close this, close this. I'll let you take a look at that in the future on your own. And tables, and then there should be a control table somewhere. So there's a control table here. And if we take a quick look at the control table, it has a source schema, a source table name, a data lake name, a data lake path, a data lake file name, a target, and so on. And see this right now, it says these are not active, so it's not going to run these. So that's why we're only seeing one table being executed. So we could run, theoretically, an update script before we schedule this and say, hey, run this one job, or we can run them all. We could set up different schedules. So now what I'm going to do is I'm going to update, right? And we're going to update this table, and I'm going to set the active flag, okay, equal to a yes. So now I'm going to have, okay, all of them run. So if we take another look at the table, make sure the update's correct, they're all ready to go. The last one is that because the fact internet sales is incremental, it needs to run a PostSQL statement, which is the upsert. So it has a call right here. So that's only the difference that we see. So now, if we go back to the parent, which is here, and we say trigger now, and then we hit OK, I'm going to close all this. And we can start going ahead and look at how this executes. So if we go to monitoring, we can see it's executing. And so we can see this is doing a lookup, right? So the input, okay. So, and the output is from this table, and we can see that, whoops, is 1, 2, 3, 4, 5, all the way down to 8 different tables we want to copy data from, which is awesome. So if we hit refresh and bring this up, see if this goes up a little more. Okay, we can see that it did it for each. Okay. And then it's doing this load. So if we go into this job, see if I can get into the job, maybe a refresh. Okay, so it succeeded already. So, and if we look at this child job, the run, we can see what it did. And so we can go back to this, and it actually pulled over, it ran the customer. And we can see it did a copy, and it did it again. So I'm curious, if we go back here, do we have another file? No, we don't, because we're not using time, so it overwrote the file. So the next one after customer would be date. And guess what? Date completed. Wow, this is really easy. This is metadata-driven ETL. Geometry is done. Awesome, right? Product. Oops, it's working on product. So you can see how easy this can be to actually just run these. What's different with the incremental? Let's take a quick look, and I want to move on to mapping data flows, and I'm going to assume that you can play with this later. The incremental, before we just did a copy and a copy. This time we're going to set the variable, right? And the copy data, okay, on this one, source, okay, it does a SQL statement. And if we look at the SQL statement, okay, which would be this one, we're actually creating a dynamic where statement. So we can say select star from our source table, given the schema, where I knew this one is hard-coded, or the date key is greater than this. So in the future, if you want to do this, we would also maybe put not only the store procedure we have to run at the upsert, but maybe we would dynamically go ahead and replace the actual key field that we're doing a comparison with. So we're incrementally copying SQL data to a Parquet file, and then incrementally, loading it, that full Parquet file into the final. So that's how we did incrementals there. Describe changes. Okay, so let's look at mapping data flows. So there was 2 examples we wanted to talk about. One was, how do we do a upsert, right? And this is the one we're currently about to do, the upsert fact, right? And in code, it's pretty straightforward, right? So let's see if I can get this. Okay, so let's look at the code. So if we go to the code and we want to do an upsert on the final destinations, right? Programs, store procedures. We can see that the upsert okay, uses the merge statement. And some people might say that the merge statement has some problems. If you do see some problems, and Aaron Bertrand has a great article on it, then go ahead and take a look, and you can change it to if it doesn't exist, then do an insert. If it exists, then do an update. But the merges works fine here first for me. And so what I'm doing is I'm joining on order number and line number, right? And I'm updating everything if there's a match, and if not, I'm doing an insert. So very straightforward. And remember, we talked about the watermark. The watermark is actually using, you know, a order date key. And so we're just updating at the very end. Okay. So that's what the upsert does. So how do we replace that same functionality using ADF? So what we have to do is we have to define a source, and we can see the source is the staging internet sales. Okay. And the destination is the fact DBO. And what we want to do is we want to join them, left join, okay, on outer. And what we can say is that insert if the sales number is null. So if the sales number, when we join these, left join, is null, then it doesn't exist in the target, then we want to add it. If it does, then we want to update it, okay? And then the last thing we need to do is, because this we want to reselect all the products. And the reason why we have to do this is that before this, we would have seen that there is two sets, okay? Two sets of data, because one set is the source and one set is the target. Now let's talk about one of the things you have to do when you do mapping data flows. At this point, I can't look at anything, right? I have to turn a debug on, and it's gonna deploy a cluster for me to work with. So right now, I can't do any actions, okay? I actually have to go ahead, okay, and go ahead and actually stop this cluster, okay? So while I'm waiting for that cluster to come up, we can talk about wrangling data flows, because that doesn't need a cluster, okay? Again, I would not spend too much time on it. This is just an interesting oddity out there, and I just want to share it, but I'm going to talk why it's, you know, not good. One of the things you might want to do with trying to do an upsert with wrangling data flows, and I was unable to do it, was that we might want to go ahead and figure out what's new to add. So what I might want to do is I might want to join the stage table with the original table. And if there's any match, then pick the stuff that doesn't have a match, right? So if it doesn't exist, then pick it. The reason why we want to do it is either that A, I don't need to merge into it, and B, it's an insert, right? So we know that, and then last but not least, we put it back. The problem is that this interface actually says it's too complex to understand. So when you use a wrangling data flow, one of the things you can do is you specify the sources, okay? So we can see that we're going from ADF. D is the document, right? And we have VDM prep. Why is this VDM prep here? Well, if I remember right, is VDM prep. And select. Okay, and this is actually scripting it. Let's take a look. Okay, so one of the things it does some actual, you know, calculations, which was part of the original VM prep. But there's one thing I had to actually add. For some reason, the actual wrangling data flows do not understand what the money data type is. And the money data type has been part of SQL for a long time. So a way around this is to try to do a try cast. Unlike a cast which fails, a try cast will turn it to null if it doesn't able to convert it. Otherwise, I'm going to cast it to a real value, okay? So that's what that code's doing. So if we look at, we bring that ADF doc in, okay? And this is EventWorks. It tells us, here's all the tables, and the input table is this table that we just talked about, and the user query. Okay, and this is the step. So we did the source, right? And what we want to do is we want to remove some columns, and then we're going to reorder, rename, and regroup. And I'm going to do the same feature in the mapping data flow, and we'll see what's different. As you can see, this is really small, so I'm going to keep remove columns. So I'm going to keep model, region, okay, year, month, quantity, and amount. I'm going to reorder it. So this is kind of just like Power BI. If you're familiar with Power BI, it's the same interface. So month, I'm at year, month, region, model, quantity, amount, and then I'm going to rename. So report, region, year, month, and then these, and then I'm going to group. And in group, I am going to get a total quantity, total amount, and at the very end, it sticks it back into the destination. Okay. So that's how Wrangling data flows work. I think they're interesting oddity. I would not suggest doing too much work in them right now. Okay, did my data flow come up? If not, we'll just talk about it, and when it comes up, I'll talk one more minute and wrap it up. I promise I'll wrap in 5 minutes. It'll be 20 minutes over. Again, this is a very lengthy talk, but there's a lot to cover. Okay, so today it's a bad day in Azure. My Databricks cluster is still running, so let's go to the last one. So you could try to do the upsert, like I said, and if you look at the upsert, you're going to see that this fails. Let's see if we can run it. It'll tell us that's too complex, and that's why I don't think this is ready for prime time. So again, if I run it, so we hit here, it's going to try to run it. Close. Let's try this. Transform. I always forget which one to do. Done. Did it go? Let's see. Again, mapping data flows, this is probably why it's still in preview. This is slow as snails. Let's see if we can do pipelines. Okay, mapping data flow, Wrangling data flow, try it. So we talked about the aggregate. This one, again, I'll let you look at it. It basically says it's too complicated. Let's look at the aggregation, how to do it in actual mapping data flow. Hey, guess what? I debugged up, so we can actually start looking at stuff. So we can see that this is FX data map view, okay? And what we can do is, this is why I talked about batch size and recommitted we can change. We hit data preview, and if we hit refresh, it's actually going to pull some data. And let's look at the destination and clear it. So you'll believe that I actually ran something instead of smoke and mirrors. So this is a report, sales by month region. And if we select this, we can see that there's 291 rows. I'm going to do a truncate table, and I'm just going to run the last 2 data frames from scratch again. So truncate, and then we do this, select, boom, no data. So if we go back to here, we can see it's pulling up the data. We can aggregate. So aggregate, you can tell it which ones to group by. You can also tell it what the aggregates are. So we want to do total quantity, sum. We want to select some columns, right? So we want to change it, report year, report month, report model, so on. And then we want to show the destination, right? So that's running. So what we want to do is mapping data flow right here. This calls it, and this is upsert. This was the aggregate we wanted to look at, right? So it's this one. Come on, 6. And debug. So debug is a little different than trigger. It actually runs it local. So we can actually take a look. So we see the inputs and we can actually look at the outputs. The outputs for a mapping data flow are different. So we can see that there's a sink, an aggregate, a select, and a destination. And we can see it's still running. So let's wrap up. So Azure Data Factory supports both ELT and ETL designs. Pipelines, activities, datasets, and link services are part of the orchestration engine. If you're going to go down this road, you're going to use the copy activity, and then it's going to be an EL, right? So you're going to extract and load it somewhere. Usually additional compute has to come somewhere, so it's going to be either RDMS with a transform, like a stored procedure. It could also be a Databricks notebook. Recently, Microsoft worked with Databricks to create mapping data flows. It does support ETL, okay? One of the things is remember that it starts with a source, 0 more translations, ends with a destination, and you know, with mapping data flows, you can do multiple transformations in the same flow, but the actual data sets have to be born from Azure, okay? What do I think? Is there any right or wrong way to do ETL? It all depends upon, you know, your business line managers. How accurate, you know, does the process perform accurately to move the data, right? Does the process execute in the time frame and use a reasonable amount of resources? Does it scale when the data increases, right? Maybe you'll find that the pipeline doesn't scale, but the Databricks does, right? And is the monthly budget what you can stomach, okay? So in, you know, Azure Data Factory offers both an ETL and ELT process. I suggest sticking with pipelines and mapping data flows. Wrangling data flows are definitely an oddity, but I would not start using them right now since it's still in preview. There's a bunch of references here, and I want to thank everyone for staying with me an extra 20 minutes, and thank you for your time. And I also like to thank Jason for allowing me to be so long-winded and talk about Azure Data Factory tonight.
All right, excellent. Thanks, John. And we do have a number of questions, but we are kind of at the end of the time. Do you have contact information that you'd like people to use to reach out if they have questions?
Sure. Why don't I put that down here? I'm going to type Notepad, okay? And this is pretty much my public email address. So if you type this.com and put the topic or subject, just put down BC chapter questions. Give me a couple hours. Obviously, I have to get back to work. I will get back to you.
All right, sounds great. Yeah, so for those of you that do have outstanding questions, please reach out to John. And thank you, everyone, for attending today. Thank you, John. The feedback that came through throughout the session is people are really enjoyed this. So this has been an excellent session for all of us, I believe.
Hey, thank you. And like I said, reach out to me if you have any questions and look at MS SQL tips. I do publish a lot there, and some of these questions might be answered already.
All right, thank you, and goodbye, everyone.
Have a great day. Bye.